Hello again. All right. Oh, sorry, my cat's getting into everything. Say hello. This is Hiccup. Hi, Hiccup. Okay. So today we're going to talk about malaria, and malaria has been eliminated from the U.S. for quite a long time, but it used to be endemic here. So mosquitoes are basically mass murderers. Sorry, but that's the truth. They are the most prodigious killers of humans. They cause West Nile virus, dengue fever, Zika virus, yellow fever, and lots of different kinds of encephalitis. And then malaria, they've killed approximately 4 to 5% of the entire human population over all time. Sounds like a mass murderer to me. Yeah, this is one of those species I don't like. So I don't like viruses and I don't like mosquitoes. Love bacteria. There goes Hiccup. He's a new kitten, so forgive him. All right, so malaria, parasites have existed longer than mankind. So that's a long, long time ago, 100,000 years or something. They were found in ancient Mesopotamia, Egyptian mummies, Indian writings, like some of the other really old diseases we've known. Homer, Plato, Sophocles, Hippocrates, they all remarked that malaria or this disease was common when Sirius, the dog star, was in the planets, in the space, and whatever, in the sky, in the night sky. I guess that's what I'm looking for, in late summer and autumn. And that's obviously when malaria strikes in the summer and then continues for several weeks or months or years after that. So in 270, there are writings about it in basically the an encyclopedia of medicine called the Ni Chen, and it included tertiary and quartan fevers, which are malaria fevers, and they were common with enlargement of the spleen. And so both of those are hallmarks of malaria. And they blamed malaria's headache, chills, and fevers on three demons: one carrying a hammer, one carrying a pail of water, and one carrying a stove. So headache, wet, and a stove hot. So we'll see why that happens. In the United States in 1607, it became epidemic in the Jamestown settlement, which was the very first settlement in the United States. It was brought over by European settlers, West African slaves, and infected Native Americans. Quickly spread to the Carolinas, Maryland, Georgia, Alabama, Florida. Kind of down that East Coast. And then it moved west to Ohio, Missouri, and then the Gulf of Mexico. It was epidemic in Europe. And we had a continual flow of workers and immigrants coming from England who brought the disease over with them. And then in the Carolinas, they were growing a lot of rice, and that was an ideal habitat for mosquitoes. If you've ever heard any of the public service messages that are on TV about clearing out anything, even little planters or cups that may have water in them, because those are all really good breeding places for mosquitoes. Also, in our history, there was poor sewage, poor drainage, and all of those are a great environment for mosquitoes. So, ugh. George Washington, Abraham Lincoln, Ulysses S. Grant, three of our presidents all suffered from malaria. And every state in America, except Alaska, because it's freezing, was malaria endemic, meaning it was there and wasn't going anywhere. It didn't cause any pandemics. Well, didn't usually cause any pandemics. And then in 1906, during the construction of the Panama Canal, 21,000 of 26,000 workers were affected by malaria. And that is down between North America and South America. So right near the equator, which, is just prime property for mosquitoes. During World War II, 500,000 soldiers deployed to malaria endemic areas, such as the Philippines, some of the other islands out there, and 60,000 of those soldiers died from malaria during the African and South Pacific campaigns. Not a cause of death you generally think about during war, but it was a big one. The word malaria comes from two Italian words, mala and aria, and that means bad and air. So obviously we're back to miasma. This term was quoted or developed by Giovanni Maria Lanchisi in 1717, who caused or who theorized it came from the poisonous vapors of the swamps around his country. The organism was first ID'd in 1880. And since 1900, the area of the world that's exposed to malaria has been cut in half. Yet, 2 billion more people are presently exposed. So even though we've cut the geography in half, it's still a huge continuing problem. So prevalence in 2020, so 2 years ago, there were 241 million cases of malaria worldwide. It kills more children worldwide than any other infectious disease. There were 627,000 deaths in 2020. In the African region, that has about 95% of malaria cases and about the same amount of malarial deaths. Children under 5 are about 80% of malarial deaths. So it's a really sad statistic. 10% of the world population is infected each year. And here's where you can see just kind of a graphic view of where malaria is present. In the blue areas, malaria transmission is not currently being transmitted. The yellow areas, it's transmitted in some places, and in the red areas, it's transmitted throughout the area. So you can see right across that kind of band of the equator is where it is most prevalent. So in the United States, as I mentioned, it was previously malaria endemic. In 1951, it was declared eliminated completely. However, we do still have approximately 1,500 malaria cases per year and about 5 deaths per year. 63 outbreaks in the United States between 1957 and 2011, but these were not due to mosquitoes that were original to the United States. So what happened is travelers obtained malaria, got sick from malaria in another country. They brought it back, and then the mosquitoes in that particular area where they lived, who bit them subsequently, then transmitted it to others in the area. So although they didn't get it from the actual person who, they weren't a zero case. They weren't, like bitten by a mosquito. Well, how am I going to say this? I think you know what I mean. They were bitten by a mosquito who got infected from a person who was in another country. I think that sums it up. All right. So where do our travelers get malaria? Well, from all of these countries. So you can see the most common area. If you look kind of in the center, you'll see West Africa is 48%. And then if you go over to South Asia, it's 6.8%. And then East Africa is 11.8%. So those are kind of the biggest areas, Africa, and then Southeastern Asia, India, a little bit of Vietnam, some of those areas. There it is. That's the nasty guy. I hate that guy. So here he is. He's sticking his proboscis into a human arm, I'm guessing. And his proboscis is pretty sharp. Makes it easy for him to penetrate the skin. Here's a diagram of the mosquito, and you can see he has 2 antennae, has a couple of other structures, the labrum, the maxillary palps, but just below that, you can see his proboscis, and you can see it's got a pointy end. So let's look at that pointy end. The pointy end is on the left, and a needle that has been used to draw blood is on the right. So it looks very similar to that needle. It's very sharp, and therefore he or she very easily is able to puncture our skin and draw our blood, just like a needle. What causes malaria? Well, it is a protozoan. We're talking about protozoans this time, which is a single-celled parasite of the genus Plasmodium. So there are several different types of malaria. So you might have Plasmodium vivax, so you might have Plasmodium malariae, Plasmodium ovale. So there's several different species, but they're all in this genus Plasmodium. So that's their first name, Plasmodium. And they're transmitted via the Anopheles mosquito, which bites us. There's lots of different kinds of mosquitoes, and Anopheles mosquitoes is just one of them. And it is more common in some of the areas where we just looked at. So the life cycle is very complex of this protozoan. The mosquito But first of all, mosquito becomes infected with malaria after biting an infected person. So someone, he's roaming around looking for a bite, looking for a blood meal, and he bites someone and they just happen to have malaria. So this newly infected mosquito will then zzz around and bite a non-infected person. And in his saliva, he has non-clotting factors. So that's to prevent, like when he pokes his needle in, he doesn't, or his proboscis in, he doesn't want the blood to clot because he wants to suck it up. So he sends in this material to prevent clotting. And when he does that, then the parasite that is in his saliva then enters into the new human. And in the new human, it's going to enter his blood, the person's bloodstream, and then it travels to the liver. Then, while in the liver, the parasites mature and then they reproduce asexually. So that means they just reproduce themselves like a bunch of times. So tens of thousands of times with just one malaria parasite. The more you have, the more you're going to reproduce, obviously. Then, once they've matured and reproduced, they're going to leave the liver and they're going to go back and infect many more red blood cells. Then they grow and reproduce again in the blood cells. And then they burst from these red blood cells and just get into the, the fluid of your circulatory system. So I mentioned there were several different Plasmodium vivax, Plasmodium malariae, Plasmodium ovale, there's several more. But anyway, depending on which species, their life cycle has a different infect the red cell and burst the red cell stage. Okay, so and we'll talk about that a little bit more. But there are fever and chills when the red cells burst. Okay, so if you have fever and chills, like we just talked about, the Chinese Minche, they had every 3 days and every 4 days. So those are two different species. When the red cells burst, the person gets fever and chills at 3 days, or the person gets fever and chills at 4 days. So that's when the blood cells rupture. And then once they're out into just the fluid of the blood, the plasma, then they can reinfect new blood cells and excuse me. And then they grow and reproduce and do more. So you can see this is just a really ongoing bad news scenario. This is a blood smear that shows some malaria parasites in it. They look kind of like white blood cells, but they are actually red blood cells. And you can see there's kind of a half ring in one, or a ring, and that's typical of malaria. So the one with the arrow on the left, you can see kind of a large ring. If you go over even more with no arrow, you can see kind of the smaller ring that's infected this particular blood cell. As I mentioned, their life cycle is very complex. So you don't have to learn this, but just to kind of give you an idea in case you're really into malaria, they first become a hepatocyte, go to the liver, then they're a schizont, and then they release merozoites, and they infect the blood sites, which is erythrocytes, trophozoites, schizonts, gametocytes, microgametocytes, and microgametocytes. Then you get the picture, right? You don't need to know this. There's too many crazy steps in this. That's for a biology major, maybe even a parasitology major to study. This is what you need to know. The life cycle. So on the left, the infected mosquito bites the person who becomes infected. They go down to the liver, they infect the liver, they grow and mature. And from the liver, they go into the blood system, they infect the white blood cells. The white blood cells, they grow and reproduce, and then they burst. And then the mosquitoes pick up more blood cells or more malaria parasites in their saliva and carry it. So they grow and reproduce in two sites, first in the liver, next in the red blood cells. So the incubation period for malaria is pretty long. It's 7 to 30 days. And again, this is dependent upon the species. And then you have a brief, what's called a prodrome, which is kind of, you're just not feeling quite right, but you don't have the disease yet. Excuse me. And then you get excuse me, you get a fever and headache and kind of some body aches. And then that's when the symptoms really start. They start with a really cold, shaking chill. So you're freezing, you're just freezing and you can't get warm. And that lasts a quarter of an hour to a full hour. Then you get the fever stage, and that lasts for about 24 hours. You can have a fever up to 105. And when you get a fever that high, you typically breathe very rapidly. And you might also have a rapid heart rate because your body is trying to cool you down with that, really high fever. You may also have convulsions. Anything after over 104, 103. Sometimes in adults, you can have convulsions. You also will probably have flushed and very dry skin. So your chills are over and you're just, not feeling good. Also, you might have nausea, vomiting, and a headache. Next, after chills, after fever, comes the wet stage. And this is several hours after the fever. Your body temperature drops quickly to normal, but you're sweating like crazy. You're just sweating and you start to feel better, but that's just one cycle. So I'm going to think back to the Chinese, the hammer, the oh gosh, now I forgot it. The hammer and the well. I know those. What's the other one? Oh well, I'll think of it in a minute. But you can see how those correlate to these symptoms. So here are the cyclic symptoms, and they alternate every 26 to 24 hours. And again, that's based on the species generally. First, you get fever, then you get chills, then you get sweating, and then you get full body shaking, which is often the first sign that you're going to have a cycle. Other symptoms, you could have abdominal pain, muscle pain, joint pain, fatigue, diarrhea, cough. These are much less common, but not to, they're possible with this. And then you can have some severe complications, some minor complications, all the way up to severe complications. All right, well, now you're rupturing blood cells. So if you're doing that, your body can't keep up with the red cell production, then you're going to get anemia. Also, your liver has to take care of all of those broken red blood cells and all the chemicals inside of them. So all of those are being filtered out by the liver. And so you may get jaundice, which is yellowing of the skin and the whites of your eyes. And eventually you could have liver failure because your liver just cannot keep up. You could also go into shock, which is a sudden drop in blood pressure, and that's typically due to the high fever. You could get pulmonary edema, which is in your lungs. Your body is pumping, fluids and trying to keep up with everything, and your lungs may not be able to keep up as well. And then you might get acute respiratory distress syndrome, which basically just means you're not able to breathe or you're having trouble breathing, great deal of trouble breathing. And you could get hypoglycemia, which is low blood sugar. Obviously, you're not going to want to eat. And then because of all of the broken red cells and they're being filtered by the liver and then also by the spleen, if they can't keep up, then those red cells may end up in your urine. And before they go into your urine, or while your urine is being made, they're in your kidneys, and that can cause kidney failure. And then I mentioned the spleen. So the spleen, if it's can't keep up or it's just overloaded, then it can swell and even rupture. And then finally, some of the most serious symptoms, you could go into coma or you could die. And as you can see right there, there's an Anopheles mosquito with his proboscis stuck right into someone's skin. And you can see his belly is kind of red, meaning he's got some blood in there. So there are 5 species I've been talking about before. I talked about Plasmodium, and then there's how these other species. Well, there are 5 species of malarial parasites. So there is Plasmodium falciparum, and this is the most serious. It can progress to very severe illness and death within 24 to 48 hours. Then we also have Plasmodium vivax, and that one is the second worst. And then Plasmodium ovale, Plasmodium malariae, and Plasmodium noelski. Okay, so there are, though, 3 basic types of malaria illness, and these are the tertian and the quartan. So the tertian means that there's fever, the cycle repeats every 3 days. So it's called benign tertian because it's not as serious. You're sick, but it typically doesn't kill you. Okay, and so that is for Plasmodium vivax and Plasmodium ovale. It can remain in the liver, and if you don't have treatment, or if you have bad treatment, and then it can continue to cause havoc in your body. It will grow in your liver, reinfect red blood cells, burst the red cells. You get all those symptoms again. And so you can have relapsing malaria that lasts for many, many years after your initial exposure. And then you can have benign Wharton. And again, you're sick with the disease, but it's not the serious, really bad type. So with this one, you get a fever every 4 days. And the same is true. It can stay in your liver and continue to infect your liver and then your red blood cells and cause the symptoms. And that would be every 4th day. Then we have the malignant tertian, and this is Plasmodium falciparum. This is the one you don't want to get. If you have to get a malaria, get one of those other 4. This one is just bad news. With falciparum, the cold stage is less pronounced, so you don't have quite as much shaking and freezing. But the fever stage is longer and very intense, and it often is continuous. So if it is recurring, it usually happens every 2, occasionally 3 days, but it's almost always just a bad fever, and it continues. It doesn't have a wet stage. The wet stage was the one where your fever drops and then you just sweat like crazy. This one doesn't have it because it just stays in the fever stage. It's the most dangerous, and you can get complications from the capillary blockage. So as your red cells burst, they're fragments, and they can block your capillaries. You can have convulsions, you can have coma, you can go into acute pulmonary insufficiency or inability to breathe, even cardiac failure. So it's really, really bad. Large numbers of erythrocytes are parasitized and destroyed. So this one is just really, really invading your red blood cells. And that's what causes all of these complications, because you need your blood in order to function properly. And because another symptom, because you're breaking up all these red cells, is you might have very dark colored urine. And when your red blood cells open up, it releases hemoglobin. And so the hemoglobin then will get into your urine, which is called hemoglobinuria. And then you can also have kidney failure from that. So falciparum is a bad one. So you want to seek medical help if you experience a fever while living in or after traveling to a high-risk malaria region if you have not taken medication. And even if you have taken medication, I would still seek medical care if you got a high fever. So what are other modes of transmission? Obviously, the mosquito bite, that's very common, but it can also be transmitted from mother to unborn child. There is some transfer of blood in placenta, and then blood transfusions or sharing needles from drug injection. If a person has malaria, then they can transmit it that way as well. The blood supply, there's an opportunity for this to be in the blood supply, but there's very careful screening of our blood supply now. So getting malaria through a transfusion is very, very rare. The only instance I think where it might happen is if there was like a huge accident or something and they were just screaming for blood donors, and then people went in and they had to shortcut some of their blood screening, then I think that could be possible, but not very common. And if you're in a malaria endemic area, you don't want to give blood up to a year after that, just in case it shows up. And then if you're a former resident of an endemic area, they suggest that you wait to donate blood for 3 years. And then if you've had a diagnosis of malaria, then they want you to wait 3 years after getting the diagnosis and getting cured before you donate blood. So very important to keep the blood supply in good shape. So diagnosis, we saw a slide similar to this. We see parasitized erythrocytes or red blood cells in blood smears. So there you can see kind of the rings of malaria. We also have antibody tests. So that's after your symptoms appear. So you can, you're feeling bad, and so then they do the antibody test and or the blood smear, because sometimes one of them will be positive and the other one won't. So this, you don't have to know all of these. I just want to present this to you so that you can see that there are different kinds of rings and different kinds of, these are all different parts of the life cycle, the trophozoite, the schizont, the gametocyte. So all of these look different based on the type of malaria you have. So they are able, in most cases, to tell if you have falciparum versus one of the other benign malarias. All are treatable, but yeah, it's important that they get right on falciparum. So how do you prevent malaria? Well, it's pretty easy. You need to wear insect repellent, particularly one that has DEET in it, which is diethyltoluamine. And you want to put that on any exposed skin. So your face, your hands, whatever. Some people are sensitive to DEET in that, they can have some severe reactions. So before you use an insecticide that has DEET in it, you might want to put it on a little small area just to see if you have some kind of reaction. And then you also want to wear long sleeves, long pants, especially if you're in a malaria prone zone. So this one, I just looked this up on Amazon, and you can have an insect shield hoodie. Cost you about $50, which is a little expensive, but malaria is more expensive. Then if you live in a malaria, or if you're visiting a malaria prone area, you want to just drape mosquito netting over your bed, spray it with insecticide, spray yourself with insecticide, and then put screens on windows and doors. You can see this person has their mosquito net on, but the windows are wide open. So probably not the best scenario. Although in some of these areas where it's really hot, you just have to leave the window open. So this is another kind of insecticide. This is permethrin, and this is typically used for things that are not people, clothing, mosquito nets, your sleeping bags, anything like that. So fabrics or hard surfaces, anything that, might help to prevent a mosquito getting past it and getting into you. So that also is available at almost every place. This one is just a brand name Sawyer, and it treats garments and other things, and has that permethrin in it. And then you can also prevent malaria with drug therapy. So if you're going to travel, especially to a malaria endemic area, then you should go to the doctor a couple of weeks before you travel, and make sure you have any vaccinations that are recommended. And if you're going to a malaria area, you probably want to take some malaria preventative. The type of medication you received is based on the country, because different countries have different levels of different malarias. And also it's based on your age, how long you have before your trip, other drugs you're taking, all that kind of stuff. So it's important to talk to your healthcare provider early, at least 2 weeks. You can do this, 2 months, 3 months, 5 months. As long as you're going, it's best to go in and start taking care of it. Now, my daughter was given doxycycline. She was on a mission trip to Honduras. And she and her friend, they're like, why do we have to take these? These are dumb. She was like, I think 14, 15 at the time. So they just stopped taking them. Mother was not happy. She didn't get malaria, thank God. But, I was a little angry. It's hard to impress upon teenagers some things, the importance of it. So how do we treat it once you get it? Well, in 1640, Juan del Vego learned that the tincture of the cinchona bark treated malaria and helped to get rid of the symptoms. And then in 1656, so about almost 15 years later, 15, 20 years, it was used in England by Dr. John Medford. And then a couple of people, Pelletier and Caventau in France, were able to extract quinine alkaloids, which they named quinine and cinchonine. And these are what was used. Quinine was used for years and years and years and years, decades, centuries even, for treating malaria. It's still used in some places, but not all over. So this is the cinchona tree, cinchona, I think that's how you pronounce it. And you can see the bark down here. It looks a little bit like cedar or vanilla or something. And from that, you can get the extract to create the quinine. And now we typically use prescription drugs to treat malaria. And again, it depends on which malaria you have, where you got infected, your age, how sick you are, if you have other comorbidities, and if you're pregnant, obviously, that's another important factor. So I want to talk about sickle cell anemia, because this is kind of fascinating. So sickle cell anemia affects mostly people of African descent. So African Americans, people living in London who are from African descent, and people still living in Africa, obviously. So what happens with sickle cell anemia, if you haven't heard of it, your red cells, which are normally round, begin to sickle. So they kind of create a C. And in doing so, they don't carry hemoglobin very well. And so when they convert into that C, which they do, kind of on and on, not continuously, but kind of repeatedly, then you'll have what's called a sickle cell crisis, which is where your bones ache, your joints ache, everything kind of hurts. And that means that you're having an outbreak of those kind of sickled red cells. Well, interestingly, here on the left, we see in green where malaria is most endemic, epidemic, whatever. And then on the right, we can see where sickle cell anemia occurs most, is most endemic and epidemic, et cetera. Okay, so they pretty much correspond, if you can see that. I mean, it's not exactly one-to-one, but it's pretty dang close. So sickle cell trait are not as affected by malaria compared to those with normal hemoglobin. Okay, so 50 to 90% fewer parasites in their blood, and they're able to get rid of parasites faster. So they have lower hospitalization rates and milder cases. Malarial parasites normally invade perfectly healthy round red blood cells with normal hemoglobin. Okay? Malaria triggers the sickle cells to change their shape. Okay, so they're normally round, and then when they're infected with malaria, they change their shape into a C. That's not the only thing that causes them to sickle their cells, but it is one of the things. And then once they have these sickled cells, your blood system, your immune system says, those aren't right. We got to get rid of those. So they come along and they phagocytize them, chomp them all up and get rid of them. And then you're left with more normal hemoglobin, and your blood continues to make blood cells with normal and sickle cell hemoglobin. So this misshapen hemoglobin that causes the red cells to sickle affects the ability of the parasite, the malaria, to infect that cell. So what does that mean? Well, malaria was very deadly in those areas. I mean, it's still deadly, as we saw earlier, but this mutation in the genetic code to cause the cells to sickle means that people with sickle cell trait have a better chance of surviving. So sickle cell trait came from places where malaria is the main cause of death. So it's the natural selection of those with sickle cell trait. So those who did not have sickle cell trait were more likely to die of malaria, while those who had sickle cell trait were more likely to live. And so then they went on to reproduce and create more people that had sickle cell trait. Okay, kind of interesting. Here's the map again. So you can see, once again, that's where malaria is affected. And here's where sickle cell trait shows up. Now, if you have sickle cell disease, that means you have two alleles or two genes that code for sickle cell. So that's really dangerous, but the trait is less dangerous. So anyway, natural selection of disease based on hemoglobin. So now the most important thing to impress upon you before we quit is malaria is just a plane ride away, okay? In the United States, malaria cases have been the highest since in the last 45 years. So 93% of US residents with malaria who got malaria did not take their preventative medication. Like my daughter, she was lucky, but don't do that. If you're going to be in a malaria area, you want to take your malaria preventative medication. Okay, you don't want malaria. Believe me, it's not fun. Okay, so that's malaria. I'm going to attach a few other documents on the website, so I hope you'll take a look at those. Thanks.